Hello? Okay, so my name is Brett Young. I run a BIM consulting shop out of San Francisco with offices in Portland and in District of Columbia called Modulus Consulting. I'm joined by Mark Decker, Paul Clausen, and Kai White. We're all BIM people. We're not professional programmers, so we're a collection of BIM professionals trying to do a system integration here. So we have a website, so you can check us out and look at how we've done what we've done. And we've produced a video that we can walk you through and talk about our project and show off the Revit API tied into the drone planning views.
Are we ready to roll the video?
Yeah.
We can just do that. It's all down here. Can you get it? Okay.
Let's do it from here.
Okay, so Revit My Drone, the building models we create are disconnected from reality. So the pain that we're trying to solve is connecting models to reality using drones. So at the heart of it, it is a Revit API hack that outputs to a drone planning software, ultimately to a drone. The reason we used this particular drone model is because it is hackable. It is all open source and can take in input files and then go fly them. Why are we using Revit? We use Revit every day. Revit is part of our workflow for BIM and is what we do, our primary work products with it as professionals. So how did we do it? It's a pretty standard, you geo-reference your model, and then based on the coordinates, you do the math to get to lat long and elevation when you place a camera. So you go around the job and you place all these cameras that are in a space and they're looking in a particular direction. And then you can move them around. And you can look at what the model shows you when you do that camera view. You then go up and we put a button into our API for an add-in, and it outputs a text file. This is sample output and not the actual text file. But you can tell that when you start adding cameras to go look at your building, it gets very complicated very quickly because you're defining 2 points. You're defining the camera location and where it's looking at, and the combination of those 2 things are important. So there's our building. We modeled the building. It's right outside here in Revit, and you'll see more of it in a minute. Here's where we're outputting our text file through the API. And then it gets pulled into the drone planning software of the drone, the actual interface with the drone. So there's your text file. And you can see how complicated it is. I mean, it's not a simple thing. These are only 8 camera views. And it shows a very complicated view around the building. So the results, here's the Revit model of the building, the library book sale building. There's the actual drone photo. You can see more of it in action. This is a video showing the 4 corners of the building. The drone is entirely autonomous. There's no one touching and controlling it. It is being controlled by Revit. It wouldn't be a hack if we didn't have problems. We had a propeller fall off right about now. We put it in a tree, and special thanks for Damon for going up and retrieving it for us. So, and then now we're going to watch a trailer for Godzilla. So we'll post more of our videos. Actually, I can play it right now. The main thing that we have to, Carrie, if you can play the video one, yeah, play this one. The one thing that we need to improve probably for the next hackathon is to do more about the pathways in between our viewpoints that we have, so that we can do clash detection in between the pathways and the things that we have in the building. You can see, for example, that we need clash detection of drones, yeah. We'll post it on the website, but basically it shows a drone going directly into a tree, which is really it's an LOD problem because we hadn't actually modeled the tree. Sorry. Yeah, there's a tree. So anyway, so we're very proud of what we were able to achieve. We're not programmers. We didn't write any code before we got here. The drone arrived in the mail 10 days ago. We had never flown autonomous flights before we had gotten to the hackathon. So we're very proud of what we were able to achieve.
Great work, guys. My shirt has a battle scar. It's cool. All right. So